This is a preface by way of explanation of the video that's about to follow. What I did is I've pulled out parts of the application you're looking at, which is a radio automation application, and made them into standalone programs. And I'll explain how the GTK works in each one of them. It may be illustrative if you're attempting to do an application. The one in particular is the weather application that you see here, which is part of a much larger program, but I've pulled it out and it's now a standalone program. It's still reasonably large by itself, but nonetheless it's not embedded with 10,000 lines of other things. But this is a fairly large application that has a lot of different parts to it, including SQL, includes a complete interface to the VLC API. It is designed for playing music and so forth. It has a lot of control functions built in. And I've used an awful lot of GTK. The actual code for this is available. You can download it. Just be mindful that it's still under development and that there's an awful lot of code that's kind of junky and needs to be cleaned up. I will try to pull some different parts of it out as standalone programs that may be useful. Okay, so let's look at the first application. Okay, I made a little demo application here to tie some things together. It's an application that lets you find out what the weather is in different parts of the world. It's a table of airports. Not all of them actually report data very frequently. But for example, Aachen, which is in Germany, the city is Aachen, the airport is Aachen-Meersbruck Airport, I guess it's pronounced, in Germany. If I click on the button here, you know some stuff going on in the background. That's inquiring of the database. As it turns out, it's out of date. It's August 14th, 2019 is the last time they reported. But anyway, and you notice EDKA, which is their station name, got put in this button here. If I click this button again, it'll go back and search the database for Aachen, and gets nothing, of course, again. If you do a search, like if I type in New York or NEW, I get Newark, New Bedford, New Bern, Newbury, everything that begins with NEW. If I do a space and hit Y, of course, I get down to New York. I don't know what Indianola Municipal Airport is. Doesn't seem like it should be in New York. Indianola is a town in Iowa. But anyway, I didn't make up the table. It came from NOAA. JFK, KJFK is their station name, and there's the current temperature and time and so forth. Well, it's not current time in New York at JFK. So, and we got a scroll bar here. We can scroll up and down. So what you're looking at here is a couple of things. First of all, we're looking at a text view in the background here, which is yellow text against a black background. That's the text I receive back when I do an inquiry on an airport. You're seeing a search entry box here, where as I type stuff in, it looks up what it's seen so far and adjusts the rows beneath accordingly. This is a button, just a plain old button. When you click one of these things on the left, it fills in the airport code to that button and makes the inquiry. If you press this button again, it will remake the inquiry. The assumption being once you've found the airport, you may want to do it periodically. Again, the scroll bar down here. And let's see, these are actually all buttons. So there's 6 rows of 4 buttons. These other buttons don't do anything. They're there. You could add something to it, but at the moment they're not actually doing anything. So what have I done? I've actually, of course, overwritten a lot of things. First of all, a viewport is normally black text against a gray background. Here it's yellow against a black background. The background of a entry box or a search box, they're pretty much the same thing, is normally white with gray buttons and so forth, and instead I've made it pale yellow. At least that's the way it looks on my screen. People tell me sometimes my screen doesn't look the same as theirs. Over here on the scroll bar, the normal default scroll bar is, again, gray against gray, and it's quite a bit larger. Instead, I've made it look like it's got a blue trough and a green slider ball. The first button, the one that's actually active on each row, the color has been changed to the background there. You'll notice that the box containing these buttons actually has a shadow underneath it and so forth. So there's been a bunch of CSS overrides in here and some other things. Let me get that off the screen. Let me bring up the Gtk Glade. I don't want to spend a huge amount of time. It's relatively simple. Is that we've got a window, and we've got a fixed container. We've got the text box. Here's your text box. It's got a black background at the moment. We've got a viewport, and in the viewport is a grid. That's where the buttons are going to go. The grid by default is 3 by 3, but when we actually build it in the program, it becomes 4 by 6, 4 across, 6 down. A scroll bar over on the side here. Current weather is the button here. I get these backwards all the time, so the button is current weather, and the search box is, or search entry or entry box is location. So when I get the two confused, now you know what I'm really talking about. Okay, why is this black? It's black because of CSS. Well, how did the CSS get here? The CSS got here because over here, I told it, I said custom CSS style provider, and I gave it the name of a file, gtk.css. And that means Glade is reading the gtk.css, and it is interpreting my, my layout in terms of the GTK CSS, which has some stuff in it which makes things look different. Now, gtk.css is a file. It is basically the file of CSS for Linux Mint Y. I think it is either Y or X. I forgot which one I took. I think it's Y, which I modified, which I altered. And I added some things to it. What did I add? So anyway, when I bring up this this layout, this particular project, it's going to interpret it in terms of what it sees in the CSS. Why does it see things differently? Now, let's go to the first one here, text. Text is the ID that I'm going to use inside the program to refer to this widget. That's the program name. But you'll notice, this is a text box. It's got a text buffer. If I put things in the text buffer, they end up on the screen. That's how that works. We tried that before. But now, and mention the text buffer here, and you can see the text buffer. And adjustment, by the way, goes with the scroll bar. It's the correspondent for a scroll bar. It tells us where the slider is and what the top and the bottom are and stuff like that. Anyway, go to the text window again, the text one. But over here, it has a widget name, and the widget name is weather text. In gtk.css, there is a section of the CSS code which has the label weather text. And that code is specific to this particular box. And it tells it to make a black background and a yellow text. All right? And you'll see that several places here. In the viewport, which contains the grid, there is a label called grid text. It's another section of CSS that tells it how to put together the contents of the viewport and the grid. Okay, scroll, another one. It has SGR slider. These are not the ID for this is scroll, but the CSS label is SGR slider. And what it does is it overrides the layout, the standard layout for GTK, which is gray against gray, and puts in the green against blue. If you don't like that, you could change the colors. You can make it wider, you can make it smaller. Once you get into that section of the CSS code, you can do what you want. Also, under also the shadowing in the box, that's covered in grid.text. I don't think any others were used. Okay, the top level here, there is. The top level is called window. That's the widget name. It doesn't have to be window, but it seems like a good idea. And the label of the CSS code that applies to the window as a whole is called weather. And it sets up the background colors and a few other things. It sets up the background color for the search box. As a matter of fact, that's done in weather, because anything that's attributable to the window itself is also attributable to to any of its children. So we get a couple of things here, and we get the layout, which is not particularly unusual, and we've also got these labels in the CSS, which are going to be changing the way things appear. Let's see, was there anything else I wanted to talk about on here? Not in particular that I can think of in the minute. So anyway, this is what the overall layout looks like, and we'll look at the labels later. All right, in the code, There's first of all a set of whoops, wrong one. I don't like it when it just suddenly decides to grab onto your mouse like that. And I don't have it here. Okay, so I was going to bring it up in a different way. The airports.config file here. This is the configuration file that will be read in. It's nearly 8,000 lines of all the airports that no one knows about, or at least that they have on their table. It's got the name of the city. That's the first item. Each of these tokens is separated by a $sign, and I parse these when I read them in. The $sign is the marker. There's no name that contains a $sign that I know of. Anyway, the name of the town, the name of the airport, the country, and the station name. All right, that's where I'm getting them from. Where did I get those from? I got those from, let's see, airports.dat. I'll leave these in the file. You can look at them. This I got off NOAA, and I massaged this file into the other file. And it's got a lot of information in there, various other codes, the GPS coordinates, a lot of, I forget what all the format is. It's very complicated. It's a NOAA format, and it can be found. One of the things when I translated this file into the other file, I lost some special characters, and they show up as blanks. For example, in however this is pronounced here, you'll notice there's an umlaut over the O. That would have shown up as a blank on the actual, in the other file, because I didn't handle anything outside of ASCII 7. But anyway, you could go in and edit it back in. The GTK will display it correctly. So there are some gaps like that that need to be edited. But the purpose here wasn't to create a weather bureau as such, but just to do some demonstration. The code down there, as you can see, is pretty much the expected code. There's that airports config. There's a compilation script. Compilation script has got, first of all, it's got the compilation where it reads in resource.xml and generates resource.c. Resource.xml contains links to the XML file for the Glade XML file, which would be called part1.glade, which is all XML. And it also contains a reference to the gtk.css. So that it goes through a special process where it compiles it to a C program, resource.c. You can see target equals resource.c. So it gobbles all that stuff in and makes a special C file. None of this is graphics, so it's all text, I assume. I haven't looked at it. Nothing you really want to look at anyway. When I compile, it's a standard GCC compile, but you notice there's two files that are being compiled. The output is part1.bin. The input's part1.c and resource.c. Resource.c is created up here. So when I look at part1.glade, part1.glade is incorporated into resource.c. And it means that the final binary will be self-contained. It doesn't have to read anything at runtime. Everything is already incorporated. And the rest of that compile is similar to other videos I've done. If I go to resource.xml, there's only two things in it. That's what it looks like. It's got a couple of things. First of all, stripping blanks from part1.glade. That's where part1.glade is referenced. And right after it is gtk.css. Okay, so that tells that glib program what it needs to get, and it eventually creates resource.c, which looks like that. It's all hexadecimal. Hexadecimal text, I assume. I don't know what's in there. I don't really care what's in there because I don't look at it. But that goes into my program, and it contains all of the elements from the from those two files. And gtk.css, that's the other one, is fairly... .css is fairly long. It's 4,069 lines long, and most of it is a standard Linux Mint theme, which I've hacked, and the hacking is down at the end here. Let me just put that there. These are the labels I mentioned. The # grid text, that's the label. So the material in this group is going to be applied to any widget that has grid text as its name, or whatever they ended up calling it over here. what is the correct name? Widget name. Yeah, they called it a name. You can use grid text in several places if you wanted to, and it would apply this CSS to each of those places. And you can see its colors and its size. Where is the one for, what was the one, for example, of, let me go back up here for the text view. That is weather text. And let me see, where is weather text? There it is down here. Weather text, the font family is mono. I wanted mono-spaced fonts. They looked better. They looked more weather-like. Weather Bureau always uses mono-spaced fonts. I went to bold, and I went to a font size of 12. Okay, that's what the text is going to look like. Everything else is going to look like background color black and the foreground color yellow. So I had to separate them for some reason. It wouldn't let me put both of them into the same group. Don't know why. But anyway, it obviously works now, as you saw earlier. But the color of the foreground will be yellow. That's your text, and the background's black. And that's how I played with it. There's several things. Like here's the trough for the slider. It's blue, and it gives it its the border radius is the curvature at the end at the ends. There's different border radiuses, but that's one. Minimum width and so forth and so on. You can play with the CSS, but that's how you create custom CSS. Okay, I don't have too much in here, but you can see how it works, and it's whoops, I made a change there. All right, the program. We don't want to spend forever on this video because it is relatively long, but I don't want to. But it is relatively simple. And we've got the usual includes, and we've got a definition of how many airport rows we're going to be dealing with, 8,000, just slightly less than 8,000. Excuse me, how many airports? There's only going to be 6 visible rows on the screen, but there could be there's just short of 8,000 lines in that configuration file. Okay, there's the usual widget for the window, the fixed box, fixed container, the scroll bar, the text view, the viewport that contains the grid, the search or entry box, the button that you click to repeat the search, and the interface to Builder to get the XML. Okay, on the screen, there's 24 buttons. There's only 24 buttons in the entire application. There's 6 rows of 4 each. So these are the 4 buttons, which I cleverly numbered 1, 2, 3, and 4. I could have said airport, code, city, name, and country. That's what they mean, as you can see. And each of the buttons there's going to be 6. So there's 6 airport button 1, 6 airport button 2, and so forth. So the 6 refer to the rows, and the button numbers refer to the columns going across. So those are the widgets. These are an array of widgets, an array of buttons. So it means I'm doing them internally. You can't use I don't know any way to use arrays in Glade. So the buttons have to be created in the program, as you'll see. But anyway, at any given point in time, there's only going to be 24 buttons visible, 6 rows, 4 each. And what we do is when we move the slider or we search with the entry box, what we're doing is we're changing the contents of the buttons. And that is then used when we click on them. Only one of the buttons, airport button 1, is actually active. The others are there, and you could activate them, but they're not. There's the declaration for the text buffer. That's the thing into which we put text, and it will appear at the top in yellow against a black background. The adjustment is for the scroll bar. The next one there is when you type in the search box, it goes into weather location. These are all globals. Some of them probably didn't need to be, but I like globals. Anyway, the count of the total number of airports. There is the array of pointers. Then it's an array of pointers. When it reads these things in, it will allocate memory and put the address of the allocated memory into the corresponding pointer. Code home is going to be the location in the file system of where the program is running from and where we presume I'm going to be reading the airport.config. So that's going to be, it's going to be the address /home /so-and-so and it gets down to the directory where it'll find airport.config. You could do it other ways, but that works. This is a program that parses a line from that airport.config. This is the callback button. This is the callback function for button 1. It doesn't matter. Button 1 will be on the screen 6 times. Okay, as an array. I mean, button 1, sub 0, sub 1, sub 2, up through sub 5. Okay, but every one of those instances of button 1 is going to, when you click it, it's going to go to on airport. All right, and it'll get actually the pointer to the button that actually got clicked. That's how I can distinguish between row 1, 2, 3, 4, 5, and 6. Init airports actually just builds the table and parses it initially. CSS set is a function that paints some CSS code onto a widget. It's a couple of steps, so I put it into a single function. So if you get some CSS, which would be in CSS provider, you can paint it onto the widget, the second argument, by calling this program. Current weather clicked is the callback routine for the button on the right, the one to repeat the search. Normally you don't have to declare callback functions, but in this case you do. I mean, that on current weather clicked is actually in, that's it right here, and it's actually a signal right here on current weather click. So normally when you declare something like that, you do not have to declare it as a header in your program. However, because I am calling it from my program, it's as well as having it called by GTK, I have to put a header in. GTK doesn't have to put a header. GTK builds its own header when you're doing the builder routines. The callbacks are done into a dynamic table. But in my program itself, it calls this function, so I need a header. Normally you would not. Okay, we enter the program and we initialize GTK, usual stuff. There we get the pointer to the from the resource of the Glade file, the XML. We create the window. We do the callbacks. We do the callback for window itself, which is basically die. And we do the callback signals. This establishes the dynamic table of callback addresses for signals as they come in. This is where it sets up the what do I call when I get so and such a signal. All right, there's this is very simple, fixed, and we've done this before. Fixed, scroll, text, and so forth. Current weather. The text buffers they're declared slightly differently, and the adjustment is declared slightly differently. It's got a different cast here because they're different. Entry is different too. It's got a different cast. Otherwise, I just cast everything to be a widget. It's pretty standard. All right, this routine here, readLink, actually returns a character string which contains the full file address of the program currently running. So it would be, /home /so-and-so /part1.-bin. Okay, that's what comes back. It gives me the full file address of the program currently running. Well, the program currently running is running in the current directory. So what I want to do is knock off the name of the program because I don't care. And I want to just leave the directory, and that's what I do here. I start at the end and I work backwards until I find a /, and then I drop a 0 on it, which effectively truncates the line. So code home is the address of the directory in which the program is currently running. And it therefore is also the directory, I hope, where the airports.config is. You'll notice it actually dropped the 0 on the /, so that means I'll have to put the / in later on. Init airports basically goes in there and reads that table and sets it up. Look at that in a moment. We'll look at that first after I get out of the front part here. If you come back 0, it means it read nothing. I'm afraid we're not going to do anything, so it exits. In terms of getting the high-level CSS applied to the entire project, to the entire window, we do this. It's just cookbook code. You create a CSS provider, you initialize it, you load the provider from, here's the other resource, from the resource gtk.css, which has been compiled into your program as a result. And this is all magic, but it works really well. And then you apply it to your screen. You apply it to everything in the screen that's currently running, not the whole screen, but just the part of the window that's running in your screen. And that magically applies the CSS to your window, and you're ready to go. So we show the window and all its descendants, and we go into GTK main, and it sits there waiting to process signals and to call things when signals occur. When you return from GTK main, of course, you're done. The program's over. All right. Let's see, init. Okay, nope. What is it? Airport. What is the init airports? It's is it airport init? I don't know how to type here. No, I'm not doing it very good. What is the name of the? It's init airports. All right. Here we are. Sorry, I need to learn to type. All right, this is where we read in the airports.config, nearly 8,000 lines, and we could have made this in a list structure or something. It would save a little memory, but why bother? On a machine with, 4 or 5 gigabytes of memory, a couple of thousand bytes isn't really going to make much difference in a small app. Anyway, there's where we play with code home. We copy into temp, and we slap onto the end of it /airports.config. And then we open temp for input. If the pointer comes back null or 0, it means something's wrong. We didn't get the airports.config. It's not there, or who knows what. And so we got a 0. Otherwise, we move on down and we start doing stuff. I should have put a return right in here, instead of having a giant else for the remainder of the stuff. But because eventually that's what happens, it's a return. All right. Otherwise, so we start off a row of 0, airport count of 0, initialize temp to be empty. Now here's where we start creating the buttons. Okay, we have got a row, and we are, for the first 6 lines that we read in, we're going to initialize the 6 rows of buttons that appear on the screen. After the first 6 lines that we read in, we won't be doing this. We'll just be reading them in and storing them. So the first 6 are different because we have to create the buttons. They were not created in Glade. All we have in Glade is a grid into which we can drop the buttons. All right, so we've got, we create 4 providers. Remember, we're just doing a single row. So we're going to have 4 buttons. We create 4 providers. We initialize the 4. Now, the contents of the buttons turn out to be sensitive, is that we don't want them to be too long, or the buttons will start stretching. We can set a minimum size on the buttons in GTK. We cannot set a maximum size. If you can, I don't know how to do it in CSS, GTK CSS. So instead, I have actual limits here, which I truncate by dropping a 0 on those spots. So the code, that airport or that station code, has a maximum length of 5, and city length and so forth. And that prevents them from, that corresponds to their minimum length as well. So the buttons all stay the same size. Otherwise, every time we drop something into the button, the button would change size a little bit or a lot. So the minimum and the max are going to correspond. Also, the contents of the button are going to be monospaced. That's an issue, even though we might have 2 buttons with, say, 10 characters in them. If they're not monospaced, if they're variable spaced fonts, they will take up different amounts of space, and that'll cause the buttons to wiggle, to change shape. So we are using, and the other side of this is using a mono font that keeps everything the same size. Every character will use the same size. So, all right, here is the CSS, and this is where you see where I'm doing it. This is the CSS for a button, and we're applying it. Applying it to the provider. Actually, I'm doing this multiple times. I could have done this only once, but who cares? For the first 6, you're redoing this 6 times, but it's okay. It doesn't hurt anything. First 6 rows, I just realized this is getting repeated for the first 6 rows, and it really only needs to be done once. But, oh, maybe, no, it isn't. This is done before we get into the loop. I'm sorry, we're not in the loop yet, so I did it right. Loop is where we actually start reading the stuff is down here. Here's where we're reading it. So anyway, I create a provider, and they're effectively the same. The only thing that's different is the size. And this is a minimum width of 45 pixels. You notice everything here, there's a little bit of padding. You can adjust these to your own taste. If there's not padding, they're too close to the edges and things like that. So I just want a monospace. I don't care what font family you're using as long as it's monospaced. Background, the first one has got the light blue background. The other is, I didn't specify a background. It gets the system default, which is gray. So that sets up, and then the first button is 45 pixels, 180 pixels, 280, and 100. And this took a while to work out the pixels, the size of the pixel, so the buttons would look nice. But otherwise, they're the same. The only thing that's different is the width on each one of them, the minimum width, which also, by the way, corresponds to the maximum width, and the first one is going to have a light blue background. Okay, so we have not applied them to a button. We've merely created the providers. We've created 4 providers of CSS. We will apply them to the buttons in the loop. All right, here we are in the loop. We read in a line. We read it from air. That's the file we open. We read it into temp. If it's a pound sign, we skip to the next one. In case I use a pound sign as a comment, there is no comment in there, but I've left that here. We knock off the new line character. There's a new line character at the end, and this knocks off the new line character. We go out, we find out how long it is. We back off by 1, drop a 0 there. That's where the new line character is. Okay, we now have a length, and we for the string length of temp minus the new line character +1. We have to add a +1 because there's going to be a null at the end. You have to do that. Otherwise, you will eventually hit it wrong. When you do a malloc, it tends to allocate in chunks of 16 or some other number, usually 16. And everything's fine until you get a string which is exactly 16 bytes without the null at the end. And they add the null, of course, further on, and that creates 17. So you have to account for that in your malloc. And I get that pointer, and I put that pointer in airport sub airport count, where airport count right now, let's say, is 0. It's the first one. If the value is, we ran out of memory, if it comes back with 0 or null, so that didn't work out. I should have probably put right here. I should have said airport count. Whoops. Just noticed that. That'll signal the thing up above that something went wrong. So I left that out. All right, we copy the line into the memory in question. This element of the array contains the address in memory of an area memory sufficiently large to hold temp plus its null. So it gets copied in. If airport rows is if airport count is less than airport rows, in other words, if we're in rows 0 through 5, airport rows is 6. So we're in the first 6 rows, numbered 0 through 5, 0, 1, 2, 3, 4, 5, 6, 5, excuse me. Then we want to do something special. This is where we create the buttons. First of all, we call the program that parses it. We pass down temp, and it sends back strings. You notice these were declared at the top up here. There were these guys up here. These names these arrays were already declared. So that's where they came from. If you're wondering where they magically appeared from, they were at not the top of the top of this function. So I pass down the line. It parses the line, returns back the code, city, airport, and county. I abbreviated airport silently because otherwise it would conflict with the array named airport. But that's why you notice there's no O in airport there. All right, we're going to create a row in the grid. The default grid was 3 rows by 3 columns, but we're going to put them in ourselves. So this inserts a row into the grid, and it inserts row numbered airport count. So airport count's going to be 0, 1, 2, 3, 4, or 5. Because for the first 6 rows, we'll be doing this. After the first 6, we won't. So airport count becomes the row number that we're inserting, and then we we create a button, GTK button new with label, and the label is code, city, airport, county. So we're creating 4 buttons. The first button, we would do a GTK button new with label on here. We get back a pointer, and that pointer goes into button 1 sub. The first row, of course, is 0, 1, 2, 3, 4, and 5 as we iterate on this loop. But we put the pointer to the button we created, which contains the station code, into the button. So the button is now initialized and ready and actually appearing on the screen as we do this. And then we do it for button 2, 3, and 4, creating additional buttons and initializing them with the city, airport, and country. Okay, now we apply the CSS. The button's been created, so now we can apply them. So we apply the CSS for buttons 1, 2, 3, and 4. 2, 3, and 4 are the same, but I left them as separate in case you want to actually do something. You could actually have separate CSS for each one of them, different colors or something like that. And we apply the CSS provider to the button, to button 1, button 2, button 4, and so forth. So the CSS provider, which basically it sets the others up for size, for width, and for monospace. The first one it sets width, monospace, and color. The other colors default, although you could make all of them different colors. Okay, now we are going to put the buttons into. First of all, what we're doing here is we're setting the alignment in the buttons. Where's the label going to be? And the alignment on the text in a button, it's horizontal followed by vertical. 0.0 means left or top, because you do either one. But if you're talking left right, horizontal alignment, 0 means left, 1 means right. And if you're doing vertical, 0 means top and 1 means bottom. Point find means the center. So down here we're saying that they're going to be centered. Excuse me, they're going to be at the top, and they're going to be centered within the button. Okay, it's horizontal. It's horizontal by vertical. Okay, so sorry, I got it backwards. So they're going to be left justified and in the middle of the button relative to top and bottom. There's nothing above it or below it. So the button's not higher or thicker vertically than the text is going in it. So you could probably put them both 0, 0 and it would work. But anyway, I set the alignment. Apparently I must have run into a problem because I'm doing the alignment. That aligns the text in the buttons. Okay, horizontally and vertically. You can play with it if you want to. I won't beat it to death. Okay, here's where we add the buttons to the grid. And I'm attaching the buttons to the grid, and I'm attaching them in columns 1, 2, 3, and 4. That's where the columns are specified. This is the row. Airport count is the current row. And over at the end there are the spanning of columns and rows. Is this button going to span more than one column or more than one row? And no, they're all one column and one row individually. That's what those 2 digits at the end mean. I've never really played with them, but yeah, you understand spanning. If you wanted to have a button that was on top of occupied 2 columns or something like that, that's where you'd set it. But anyway, we just want them to be 1 column apiece, and of course the columns will be different widths because the buttons are different widths, and the buttons are installed going across in the airport column. And now we have to set up the callback. This is the callback. Since we have to do the callbacks because this wasn't declared in GTK in the part 1.glade, because you can't declare arrays of them that I know of that way. So this is how you create a callback. You're telling it that when airport count is clicked is the name of the signal. You can go into the GTK documentation and you can see what each widget has a set of signals it can receive. Some of them have no signals, as it turns out, but they receive signals. The signals are named. Now, one of the signals that a button can receive is clicked. So if it receives the signal clicked, it's telling it should call the function named onAirport. Okay, that's how a callback is set up. So if the button is clicked, button 1, see, I'm only doing button 1. The other I'm leaving with no callback. So if you click them, nothing's going to happen. There's nowhere for the system to send the signal. It'll just ignore it. Okay, so for button 1, it will call the function on airport. Increment the button count. And I'm out of that, by the way. I'm out of that that bracket for we were less than the number of airports. And otherwise, down here, I increment the button count, and if I get too many, I break out. I don't set a 0. I just decremented it. It still works, but you were missing airports at the end. Now, going back up here, the when we created the when we read and parsed. Let's see. Here's where we. Let's see. A bit at the beginning here when we're going through it. Okay, we did the malloc here. Okay, that's where the line gets. Well, the line gets the malloc here. The memory gets allocated. This is where the line actually gets copied. Okay, it's only the first 6 rows that we do anything involving the buttons. After that, we don't count. All we care about is incrementing the airport count. The additional 7,900 and something, I forget what the actual number is, lines are simply stored in memory. There's nothing with a button. It's only the lines that are involved with the first 6 do we process with the buttons. But the buttons have been created and contents have been put in them. The rest of the lines are just stored in memory. And we increment the count. After the first 6, that central part is not executed. We're just reading and allocating and copying and looping until we run out of input. We run out of input. We close off the input file that we were reading, and we set up the scroll. Now we know how big the scroll is going to be. It goes from 0 to airport count. So that tells the GTK system that what it means when you're moving the scroll slider, that you can move it from 0 up to airport count. So if it's moved all the way down, that the value coming back would be airport count. You move it all the way to the top, it would be 0, and everything scaled in between. Okay, what else have we got? Airport data is down here. It's rather grungy little function. It receives these pointers to the strings, and it uses strtok string talk. The reason why I'm passing things as temporary because it modifies the string. It searches for tokens delimited by something, in this case a $, and the first time you call it, you pass down the address of the string that you're tokenizing. Subsequent calls, you pass down a null. strtok is a nasty little function and sometimes doesn't really work very well, but it works okay here. And so essentially I'm extracting each of the entries. At the very bottom, before I return here, I just go in and drop zeros at the length. If they're longer than the length, I have truncated. If they're not longer, doesn't make any difference. It didn't hurt anything. It's not worth worrying about testing it or something. Just drop the zeros there. It truncates the length of the string. You get more exotic, I suppose, by putting ellipses in, but I don't think it really makes that much of a difference. Down here is the CSS provider function, which I've used before. It's relatively simple. I won't get into it. Okay, here is... Okay, break there to get some more coffee. And what we're about to do now is looking at onAirport. onAirport is the callback function for the buttons in the grid for button 1. Okay, so if you've clicked a button 1, there are 6 of them on the screen, it will come here. And when it comes here, the address, the pointer, will actually point to the button that was clicked. All right, we're not going to get the array number or anything. We're just simply going to get the widget address of that button. And that's what we really need, because the first thing I want to do is get the label out of that button. The label in that button is... get this off the screen, is the airport station code. So I pull out the airport station code from the button. There's a blank at the end, apparently. I knock off the blank. And then I take that and I set it as the contents of the button up on the black area up on the right there. Okay, if you remember that button up there, this guy right here. Okay, it says airport here. So if you've clicked one of these buttons over here, you don't see them, but they're over here. If you click one of these, you go to on airport. On airport extracts the value that's in the button you clicked. All right, and the first thing it does is it changes the label of this button here. Okay, which is car weather, the current weather button. So that button gets as its label the label of the button you clicked. All right, the button you clicked. Let me do it again. One of these guys down the side here. So if you click on EKAH, you see EKAH popped up over here. It did the search first, by the way, and then you can, if you notice the coherence there, this was going on in the background. When it finished that, it did do the change. So the searching takes place first before. Well, the searching is taking place, and it doesn't register the change until after it's done. But yeah, so you click here, it goes to this function we're in at the moment. The function here takes that EKAH and makes it the label contents of that button there. Okay, get that off the screen. Now the reason why you didn't see it that button change until after we left this function, because the GTK doesn't update until I make a return. The button's been changed, but you're not going to see the screen update until GTK gets control again. So it's not in control. I'm down here. Okay, so I've done that. I've pulled the button out, and I click. And this here is I'm calling the function on current weather clicked. This function here doesn't really do anything except pull the label out and put it into the other button. The other button is the one that actually searches for the weather information. It is normally called by clicking it. I'm not clicking it. I'm simulating a click. I'm calling it myself. I'm calling on car weather clicked. It's as though it were clicked. And I'm passing to the function, the widget address, the pointer to the button in question. So it's as though when I get to current weather, somebody had clicked it on the screen. So here it is, conveniently right next to us. Somebody has clicked that button on the screen. And by that button, I mean this guy right here, okay? But nobody's actually clicked it if I came in from the other function. The other function has simply called this function. Works out the same way. All right, so we're down here. We've got a buffer of 24,000 characters. This is where we're going to store or concatenate the lines coming back from NOAA, the U.S. National Oceanographic and Atmospheric Administration. It's a mouthful. But anyway, the data coming back will be concatenated in there. The data is, what we're going to do is we're going to run a background task, and it is a wget, and it's going to get the information through the internet, store it in a file. The file it's going to store it in is in/temp, and I called it sgr-weather. It's not a good idea. I probably should have created a unique name, such as the process ID is guaranteed to be unique while your program is running. Nobody else has the same process ID. So instead of saying /temp/sgr-weather, I should have said /temp/process ID sgr-weather, which I could have done, but I didn't. It's not that important. So if you had two people running, they could clobber one another, is what the problem is here, but I'm not going to worry about it right now. So anyway, I am printing into the, it's an internal memory print, into buff, which is a string, a very large string. This text here, wget. Wget's a standard system function, which goes out and grabs stuff through an internet, it's an FTP site as we're talking here. T means the number of times to retry. If it doesn't work, try up to 5 times. Sometimes that happens if they're not responding. I forget what the -0 means, but it's not important anyway. You can look up whatever that means on a wget. There is the, that's the output file, excuse me. Yeah, that's where it needs to put the thing. That's where it's going to put it, -0. It's not a 0, it's an O. And the file it's going to is FTP stuff. And you know, it's way down at the end, here's a %S. %S is where you're going to put the label of the button. The label of the button is the station code. The station code.txt is where it will find the information we're looking for. That's where NOAA stores the most recently obtained information from that station. All right, so what I'm doing with the sprint is I'm just basically inserting the station code at the end of this this wget argument. All right, and then I execute it. System runs it in the background. Doesn't take long. You saw it running because when it runs, the terminal that's running it shows some messages from wget. I think they're sent to std error. I've never checked. But they're not coming directly to me. And the output of this is actually going to sgr-weather in temp. Okay, so when I get control back, it's done. And I open a file that's been declared as a file up there. And I open sgr temp, the temp/sgr-weather for input. And set I to 0, even though I'm not really using I just yet. If top... if it comes back with a pointer, if it comes back null, it means it didn't work and none of this will happen. So what I do basically is I zero out buffer, make it a 0-length string, and command 1, and I start reading it. All I'm doing is reading it and concatenating. This is not complicated. So I read into CMD1. The lines aren't that long, but I don't know what OB and cycle is. It's some code from the Weather Bureau, and I wasn't interested. They didn't have any information that I wanted, so I just ignore those lines. Otherwise, I concatenate the line into the buffer. I did not pull the new line character because I want the new line characters because I want these to appear on separate lines. I could have checked the length here. Some of these lines are a little long, and I probably coming back in CMD, and if they were too long, I could have wrapped them around or something. If they're too long going into buffer, it'll make the viewport stretch. It's not the end of the world, but it doesn't look nice. Doesn't look neat. But I didn't check it, but it's easy enough to check there and to wrap them around or something. Let's see. So that's the loop up here where I'm reading the stuff in. When I'm out of it, I have finished reading. If the string length of buffer exists, if there's something in buffer, it means we read something. If there's nothing in buffer, well, we didn't read anything. If there's something in buffer, then we put it into the viewport, and there's how we do it. We do Gtk text buffer set text, and text bar probably didn't need the casting here since it was declared that way, I think, but it doesn't hurt anyway. So into the text buffer, we put the buff, and I forget what the -1 means at the end. It's, who knows? It's some parameter, I'm not sure, off the top. But anyway, so that puts and that makes the text appear on the screen. If it was empty, if nothing came back, then we put in airport not found or not responding. We're putting in basically an error message of some kind. I close out top. It had to be running because it had to be something in top because I'm here. Down here is the else on the other case when top didn't came back with a null, and I put the same message into it. Probably could rearrange this a bit. So that sequence causes something to occur on the screen. Let's see. Next one down here is on location change. This is the entry box. Okay, so somebody starts typing in the entry box. You come here. Every time they type, you're going to come here. They're going to get it character by character. When you get the text length, it tells you the text length. And what we're going to do is pull out of the text box or the entry box. I'm not treating it as a search box. I'm treating it as an entry box, but I like the little magnifying glass. So I called it a search box. Anyway, it is an entry box underneath. I'm pulling out the current text, which gives me all the text that's been typed so far and puts it into weather location, copies it into weather location. Only so many bytes, n, where n is the total length. 512, so I don't, for some reason, if somebody just stands on the character there and types in 1,000 letters, that won't create a buffer overflow. One of those things. So it is a limited, since you're taking input from the screen, you probably want to make sure you're not getting too much of it. Okay, so I get into weather location what people have typed so far. So now I start going through the airport information. Remember, it's searching by city. The first characters in each line in the airport config are city information. It could be upper or lower case. So what I'm doing, here's the search here. First of all, it's case comp. It's insensitive to case. and it's comparing only n characters. The neighbors across the street are vacuuming their car if you're hearing a funny noise in the background. It focuses right through my window. Anyway, so airport sub I is a line of those up almost 8,000 lines. Weather location is the text they've searched for so far, and string length is the length of the text they've searched for so far. So it's looking for the leading fragment, and if it matches, then we pop in here, and we set the value of the adjustment equal to I being the row in airport where we have found the partial match. Could be a complete match, but it's most likely a partial match. That causes the scroll to, the slider to jump to that location. And once we've done that, we break. Well, the adjustment's associated with the scroll. Changing the adjustment causes the scroll bar to move, the scroll slider. When that does, it triggers another event. It triggers an event that the scroll has changed. Okay, we're done here. We're out of this subroutine. This subroutine was when you started typing. As soon as you typed a letter, it did a search. If it found a partial match, it changes the scroll bar location, and we are going to look for the scroll handler now. That's not it. This looks like it here. I don't know where it is. Let's see let's see what its name was. Its name for the handler for the scroll was on scroll value changed. So that's where it's headed now. Scroll value changed. All right, the scroll value got changed by that function down there, or if somebody dragged it, if somebody with their mouse dragged the slider itself. So what we're doing here is somewhat similar to the initialization. But we're going to have we're going to do it for 6 rows. We're going to go into those 6 rows, and we're going to change the contents of the buttons on those 6 rows. Okay, so we get the value, we get the number that's currently in where the slider is of the scroll. This tells me where I am in the slider. Where is the slider relative to top and bottom? So it comes back. It says it's at position 1,000. If it's too big, and I don't know how it could be, since that's the way we created it. Well, I guess it could be. I mean, in a sense, the I could be airport code. Well, we don't really want we want to back off six lines so we can display the last page. Even though the last value in the scroll bar is airport code, the last thing we display is going to be airport code -6. So there you are. I is equal to airport code minus, as it turns out, 6. All right. Now we get into, so we go from j is equal to I, which is the starting point in the array, up through I plus 6 airport rows, incrementing j. If so long as j is less than airport count, in other words, I don't want to go beyond the end of it, which I don't think is possible the way I've coded it. Yeah, it would be possible, but nonetheless, it's always good to put an extra. We copied into temp. Remember, when we call the parser will destroy part of it because of string strtok, so I have to make a copy. And then we call the parser here, and I wanted to add an extra line there because it looks neater. We call the parser, we pass down temp, and it sends us back the airport city, the airport code, the city, the name of the airport, and the country. We get that information back as we did before. And we change the appropriate buttons. So we change, for whatever we are, j minus I. J is where we are in the larger array. I is the starting point. So j minus I is going to be a value between 0 and 5. So in other words, one of the rows. We're on one of the rows. And we're going to change the label of the button as appropriate. Okay? So there you go. And it does it for the 6 rows. And when it's, if for some reason we got over the airport count, we break. But when we finish, we're out of there. So that altered the buttons. So let's go back here and compile. And it works. Compile works. And this is what it looks like when you see it. So again, as I start typing here, and again, New space, well, New Bedford, New space, New Bern, New York. There's I don't know if there's too many beyond that, but yeah. So you got a New Yorker here. And we click LaGuardia, and there's LaGuardia come up. So what happened there is you saw the wget Jew information in the background. When I typed this, it did a search. When it found a row, it caused the scroll bar to move. The scroll bar moving or changing the scroll value, the adjustment caused this to cause that function that we just looked at to come up and reset the buttons of here. So when I actually then clicked one of these buttons, it changed the label over here and simulated a click on this, and we got the data coming back. It's a long way around, but it's actually fairly simple. But it does give some hint as to how to do some more sophisticated applications. You notice the shading and so on. I would recommend you go in and look at the GTK to see how some of the tricks I've used in order to create like the background colors and so forth. The gtk.css, it'll be in the file that I upload to the server in a little while, and everything should work pretty well. Again, it's these airport codes have. See, I'm rolling them now. Now, when I'm doing this manually, it's not being triggered by the search routine here. It's being triggered by the actual physical movement. But there you go.